on vertex form with quadratic equations. So remember, with quadratic equations, we have the form like this. We can have x squared plus, let's say, 5x plus 3. So that's in standard form of a quadratic equation. Or you can have something like 2x squared minus 4x plus 5, and so forth. Sometimes you can have it where the a, this is the a, this is the b, this is the c, where the a has a number greater than 1. So this is the standard form of a quadratic equation. So let's look at how to make vertex form. So again, the standard form, y equals ax squared plus bx plus c. So we know that the a could be greater than 1, like here, or it could be 1. In that case, you wouldn't see the 1. Then we have the b, have a constant here, and the c has no variable, the standard form. So we're going to put it in, let's put this one, y equals 2x squared minus 4x plus 5. We'll put that, that's in standard form. We're going to put it in vertex form. Step 1, find the vertex. So it's very important now to know what are we talking about vertex. Well, when you make a quadratic equation, you make a parabola. So let's just draw a rough sketch of one. Let's say we just draw this. So as you see in this parabola, the end point here, the point where it changes direction, where now it's going down, it stops, and it goes up. So the point where it starts changing direction again, that lowest point, that's the vertex. So write the vertex there. That's the vertex, the little arrow. Of course, it doesn't have to be pointing up. You can also have parabola pointing down. In this case, it'll be the highest point. So the highest point, the lowest point. That's the vertex of the parabola in the quadratic equation. Okay, so again, we're just going to learn how to go from the standard form to the vertex form. Find the vertex. Find this piece. Now, also, when you find the vertex, you need to first find the axis of symmetry. So if we had a rough graph, let's say we had a parabola here. Let's say it was at, let's say that's -2. And we'll say 1, 2, 3. So let's say what we can see the vertex on the graph. We can see the vertex is at -3, -2. That's the vertex. The axis of symmetry, I'll move this over so we see it. The axis of symmetry is where you can cut the vertex with this dotted line in half. Equal amount on the left, equal amount on the right. That's the axis of symmetry. So what we're going to do, we can get the axis of symmetry by this formula. Okay, so I'll make the formula here. So the formula for the axis of symmetry, we'll call it x, is going to be -b over 2 times a. That's the formula. And that's something you should memorize. It's not hard to memorize. So let's look at the equation again. We had y equals 2x squared minus 4x plus 5. That's what we had. So the b is 4. The a is 2. So remember, it's minus b. So it's going to be a minus 4. Right? Because it says minus b. And 2 times a, and a happens to be 2. So it's 2 times 2. So a negative times a negative, remember, is a positive. So we're going to have 4 over 4. The axis of symmetry will be 1. That's the x. Now all we need is the y, and we have the vertex. So right here, this formula gives us the axis of symmetry, which is 1. Again, take that 1, plug it into the original equation, and you'll get y. So we had 2 times x. X we know now is 1. 1 squared is 1. 4 times 1 is 4. Don't forget that negative sign. Plus 5. And if you did all that, you'll get 3. So the vertex is 1, 3. Vertex is 1, 3. Okay, so now that we know the vertex is 1, 3, this is what vertex form looks like without numbers. So we already know what A is, right? So we're going to have y equals, well, A is 2, so there's that. Right? We're going to put the x in. The h is part of the vertex of 1. So it's minus 1 squared plus 3. So basically, this is what you're doing. You're taking whatever A was and putting it there. Whatever H was, that's the X, you're putting it there. And the K is the Y. So remember the H, X, K, Y. Basically, that's what you're doing. And you'll get this. So we've taken this in standard form and we put it in vertex form. So let's do one more. See if you can do this. Okay, so what if I gave you, I'll write an equation here. Let's say we had 3x squared plus 12x, and we'll say minus 6. So there's our quadratic equation. We have our A, our B, and our C. So again, what was the first step? Find the vertex, right? And to find the vertex, we need to first find the axis of symmetry. Right, so we're going to find x. Negative b over 2 times a. So we have the negative b, by the way, not a, there we go. So we have b is 12, so we're going to have a negative 12 over 2 times 3. 3 is a, so that would be 6. So we know our x right away is a negative 2. That's the axis of symmetry. So now what do? We plug in negative 2 into the equation. Okay, so we're going to have, and by the way, this is y, so we'll say y is going to equal 3 negative 2 squared plus 12 times negative 2 minus 6. So remember, this is in parentheses negative 2 squared, so that's going to be a 4. So we're going to have y equals 3 times 4 plus, and this is 12 times negative 2, negative 24 minus 6. Okay? And by the way, you should stop the tape and see if you can do this by yourself. Find the vertex and put it in vertex form. Anyway, to continue, we have y. So we're going to have 12 here plus negative 24 minus 6. And by the way, let's not forget that we have, this is, these are x's, and that's why we're putting the negative 2 into the x. Okay, so let's keep going. 12 plus negative 24 is negative 12, so we have a negative 12 minus 6, and we get the vertex. We're going to have the y part of the vertex, bring that up, as negative 18. Okay, you should go over this if you didn't understand it. Okay, so now we need to plug that in. So we have our vertex here. I'll say our vertex now. We have as negative 2, negative 18. And remember, let's do vertex form now. This was in standard form. Vertex form. So we're going to say now y in vertex form. We're going to have the number a. Remember, it's going to be a x minus h squared plus k. So what is a? 3. Right here in the standard form, it's 3. So we have y equals 3. It's x minus the h. Remember, the h was the x in the vertex, which we said was negative 2. So minus 2 is plus. We had a minus 2. That's why we have plus there. And the k was minus 18, so I'll put minus 18. So this, right there, don't forget it's squared, is in vertex form. So we went from standard form to vertex form. Now, there's one other thing you might be asked to do. You might be asked to prove this. Prove this is correct by turning it back into standard form. So let's do that next. I'll write it over again over here. So we said that y is going to equal 3x plus 2 squared minus 18. Right? That's what we had over here. So, again, to turn it back into standard form, this is vertex form. Let's do one at a time. Let's do x plus 2 squared. So let's make our two binomials, and we know we can do FOIL now. X times x, x times 2, and so forth. Right? First, outside, inside, last. So we're going to get x squared. X times x is x squared. X times 2 is 2x. And on this way, we have another 2x plus 4. Bring that up. We're going to have x squared plus 4x plus 4. And now, don't forget that we have minus 18 and a 3 over here on the outside. Distribute. Okay, so 3 times x squared is 3x squared. Right? If you look, so far it's going okay. That's our 3x squared. 3 times 4, x is our 12x. Right? There's our 12x. Going good so far. 3 times 4 is plus 12. Don't forget the minus 18. Okay, so if we do this now, we'll have 3x squared plus 12x minus 6. 12 minus 18 is minus 6. And there's our standard form equation. So if you do the vertex form here, which we did, and you solve it again, you distribute and solve it, you should get the original standard equation. If not, you did something wrong. You made a happy accident.